সেকশনের ক্লাস শেষ হয়নি।
শেষ হয়ে গেছে, এই দেখ শেষ হয়ে গেল এইমাত্র।
সেকশন বি কি আমার কথা শুনতে পাচ্ছে? একটু আমাকে বলো তো, মানে আমি
Yes, ma'am, শুনতে
পাচ্ছি। Yes, ma'am.
প্রবলেম হচ্ছে বুঝতে।
হ্যাঁ ম্যাম।
সেকশন বি আমার কথা শুনতে পাচ্ছো?
ম্যাডাম আমাদের কথা শুনতে পাচ্ছে না।
ম্যাম ইকো হচ্ছে ম্যাম এখন।
ঠিক আছে,
কি করছো ম্যাম?
একজনের মানে একজনেরও যদি খোলা থাকে, অডিও খোলা থাকে, তাহলে ইকো হবে।
in this sessional class what we will do here, graphically we will find out some important force component for a particular structure. For example, we can find out reactions, or we can find out member forces or bar forces, or we can find out shear force and bending moment also. But all these things we can find out,
ম্যাম কথা বোঝা যাচ্ছে না।
and we will learn here the basic of that thing only. Now, why we are learning this graphic statics? Because it leads to a basic understanding of the action of structure under applied load. And we can visualize the relation between the force and structure geometry. So here, how we can do this? Because force, displacement, all these parameters, these are vector quantities. These are vector quantities with magnitude, direction, and it also has a point of application. So here, this force and displacement part is a very important thing that we can find out graphically, which we will show here. Many problems involve some complicated formulation. If we do analytical solution. So from that point of view, graphical solution is more easy to understand, and you can readily check that. Now I'm coming to this. Now, we all know that if we have a coplanar forces, suppose this is force 1, this is force 2, so we can find the resultant of this coplanar concurrent force. If these forces are actually meeting at a single point, we can find the resultant force. Now, how we can find it? We have learned in 11-12 that there are two ways. One is the parallelogram law, and another is the triangle law. Now, basically, we can find the reactions. How we can find the reactions? We can form a polygon. So if this is our P1, and from here, if we draw the force P2, then if the body will be in equilibrium, then obviously all the force component will form a closed polygon. So this dashed line, so we have formed a closed polygon here. So this dashed line will give the reaction. So similarly, if we have more than two forces, suppose if we have this P1, P2, P3 like this, so how we can find the resultant? We will draw the force polygon here. So this line will represent P1 in terms of direction and magnitude. Then we will draw P2 from the end point of P1. Then we will draw P3. Then the closing line will give the reaction. So this construction of polygon of force is very simple one. So we will use this concept to find reactions for a particular structure, or we can find the member forces also. Now, for the first case, let us do a simple problem. Suppose we have a string like this. And here a load, suppose 10 kilonewton is acting. So what will be the tension force will come in this strings. So here, what we will do here, how we can find out? So if this bar, if this rod, we know the length of this rod, so this angle is known to us. This angle is known to us. This depth is known to us. So how we can find the forces that is coming in these two strings? So first of all, so this will be we will call this as form diagram. It will give the geometry of the structure, and we have to draw this in scale. Now, from this form diagram, using set square and scale, we will draw force diagram. Now, first of all, what we will do, we will name the spaces here. So here basically 3 forces are acting, 10 kilonewton downward and 2 forces in the 2 strings. So let us name this space as A, B and C. So here we are naming the space A, B and C. And we will name the forces in terms of this space. So this notation is known as Vows notation. So here we will name these forces in terms of spaces in a clockwise manner. That means, suppose if we draw this form diagram with suppose this point is P, this point is Q, this point is R, suppose. So then AB, space AB, we are just mentioning this AB in a clockwise manner. So it will indicate the force in member RQ. So this will indicate the force in member RQ. If we just say the name BC, so B to C, it is a clockwise manner. So then it will denote the force 10 kilonewton here. So if we name CA, then it will denote the force in member RP. Now, what we will do in the force diagram? So this 10 kilonewton force, this is a vertical force. So let us draw this 10 kilonewton force vertical. Okay. And in terms of direction and magnitude also. Suppose this is our 5 centimeter. We have to give some scale here, force diagram. Suppose 2 kilonewton is equal to 1 centimeter. Or 1 centimeter is equal to 2 kilonewton. So let us have this using scale. Suppose this is 5 centimeter. So that means it is denoting the 10 kilonewton force. What is the name of this line? In the force diagram, just conventionally, we will name this force because capital B, capital C, it is the 10 kilonewton force. So in the force diagram, we will give the name small b, small c. Okay, capital letter here, it denotes the spaces. So small b, small c, small a, this will be used in the force diagram. So small bc, this is our 10 kilonewton load. Now, using set square, we will draw a line parallel to this member RQ. And name of this force is AB. So, just using set square, we will draw a line parallel to this from here. So, this line and this line is parallel. Okay. Now we don't know the magnitude of this force. Now, from member C, just we only know that all these forces here will form an equilibrium. So, from C, small c, in the force diagram, we will draw a line parallel to PR because the force in this RP member is denoted by CA. So, from C, we will draw a line. So this line will be parallel to PR. And this line will be parallel to RQ. Because for these cases, we know the force direction, but we don't know the magnitude. So now these two forces will cut here, intersect here at point small a. So now here, you can say that suppose AB, if you measure using scale, if you measure this length, and A to B is actually we are going in this direction, and the force in this member RQ is named as AB. So you see this direction is coming in this towards Q, from R to Q, and here from A to B. So if you measure, so what I'm trying to say, that means in terms of space, the member force is denoted by AB. Okay. Now here A to B is basically A to B like this. That is, the arrow is going towards B. So in the form diagram also, the arrow will go towards Q in like this. Similarly, suppose in this force diagram, if we measure the magnitude of AC, A to C means this direction, A to C this direction. But here, in terms of space, the name of this force in RP is CA, isn't it? You see that the force in member RP, কিছু বলছিলে? So the member force in RP is denoted as CA. So here, if we measure this distance C to A, that means in this, if we give the arrow like this, if we measure the distance from C to A, then you see the arrow is coming like this, C to A. Just we have to see this form diagram and force diagram simultaneously to get the direction and magnitude of the forces. So from here, if we measure the distance small AC with scale, and then using this thing that 1 centimeter is equal to 2 kilonewtons, so whatever centimeter is coming there, so that is equal to some kilonewtons. So that will be the value of force, the magnitude of force in member RP. And again, we can find the direction also. So this is a very simple way how we can, so we can get an approximate idea that what should be the force value. আচ্ছা, এইটুকু অবধি কারো কোনো কোয়েরি আছে? একটু বলো তো।
নো ম্যাম। ইয়েস ম্যাম, এই ফোর্স ডায়াগ্রামে ডিরেকশন গুলো একবার যদি বলেন, ফোর্স ডায়াগ্রামের ডিরেকশন গুলো কি করে দিচ্ছি?
কোনটা কোনটা বলবো?
ফোর্স ডায়াগ্রামের ডিরেকশন গুলো, এই ফোর্সের মানে এসি ডিরেকশনটা ওদিকে কেন?
ম্যাম,
হ্যাঁ বলো।
ম্যাম, according to this, তাহলে force in the member PR will be 5 kilonewton, তাই তো?
হ্যাঁ, কিলোনিউটন।
Force in the PQ বলছি, RQ is also 5 kilonewton.
Force in RQ,
না, force in RQ
মানে আমি বুঝলাম না, এখানে পুরো ফোর্সের ইউনিটটাই হচ্ছে কিলোনিউটনে।
হ্যাঁ, ফোর্স ইন RP টা 5 kilonewton হবে, তাই তো?
আরে থিটাটা বললে কি করে বুঝবি? থিটাটা বলতে হবে তো।
হ্যাঁ, ফোর্স ইন RP টা
5 kilonewton হবে, তাই তো?
তো ওটা বোঝা যাবে না তো।
না, ওটা তো তুমি যখন ড্র করবে তখন বোঝা যাবে।
এটা একটা ক্লোজ ফিগার, তাহলে টোটাল 3 ফোর্সেস এর সাম আপ তো 0 হওয়া উচিত।
হ্যাঁ, কিন্তু সেটা তো ডিপেন্ড করবে তোমার থিটার উপরে। তোমার থিটা, এইচ, আমি তো এগুলো কিছু স্পেসিফাই করিনি।
মানে অ্যাঙ্গেল BC এটা 60 ডিগ্রি হবে না? মানে ওটা আমি ভাবছিলাম,
আমি এখানে সেরকম কিছু বলিনি।
আমি ভাবলাম ওটা
যেখানে
হয়তো
প্রত্যেকটা সাইড যে সমান সেরকম বলা নেই।
আমি ভাবলাম ওটা হয়তো ইকুইল্যাটারাল ট্রায়াঙ্গেল, সরি।
সাপোজ এর আগের প্রবলেমে in this case you see this h is of this height. Now here suppose the same problem, but if we reduce the h, that means the depth of the member. Okay, so that means this theta, suppose just for example, let us take, suppose for here theta is equal to, if it is suppose 45 degree, for this case suppose theta is equal to 25 degree. So that means here the depth reduces. So what do you think? What should be the force magnitude? Whether it will increase compared to the previous case or it will decrease? So where is increase? So just to understand that here we have reduced the depth. So the force magnitude will increase here. Okay, and this is very simply, just if you draw the force diagram, you can easily check this. Just I'm repeating the previous one. So if this is A, this is B, this is C, this is small b, small c. You will see the diagram will look like this. So that means this magnitude will be much more. So whatever you have said, that if we reduce this depth, then the force magnitude will increase. So this will be true for our practical cases also. You will see that whenever for a truss member or for a beam member, if you increase the depth, it will reduce the force component. But if you reduce the depth of the structure, then the force magnitude will increase. So this thing we will discuss in detail when we will solve a truss structure. Now, তোমাদের একজন বললে না যে ফোর্সের ম্যাগনিটিউডটা আর ডিরেকশনটা বোঝানোটা আরেকবার বলতে, তাই তো?
Yes sir. Direction magnitude only direction টা যে
Okay. In suppose for this here in this form diagram, so the name of the force in this member, name of this force is AB, isn't it? It will be AB or BA, because we have adopted Vows notation which is taking the convention of taking the clockwise direction. So AB means the member force. If we just take this joint from where this 10 kilonewton force is acting, then if we say AB, that means it will give us the direction of force according to this joint. This joint. So here AB means this direction A to B. So here also the same direction will come here, thinking about this joint. So that means, you know that if we have a member like this, so a member is having two joints. Now if the force is acting like this, that is away from the joint, then it is a tensile force. And if the force is acting like this, that is towards the joint, it is a compressive force. So for this case, in the form diagram, if we take this joint, then we can see that the arrow is actually away from the joint. So from this manner, we will get that the force direction is like this, which is tensile. For the force CA, if we consider this joint, then CA will denote the member force here in this member, considering this joint. So CA, the direction is C to A like this. So here, just considering this joint, the arrow will be given like this. So that means in this member also, the direction is away from the joint, that is a tensile load will act. Okay.
Yes, ma'am.
Okay. Just wait. So suppose another important thing, my pen is doing some problem here. So suppose we have a string like this. Now if we give two force here, P1, P2, then the string will deflect like this. The string will deflect like this. So this this deflection, this shape, this depends on this force value P1 and P2, and also on the position of these forces. So this deflected shape is known as funicular form. Now this funicular form, it is a form taken by a cable or rope under any given load, and it will be in tension always. So it is a funicular polygon. Now how this will be important? Now if we draw a force diagram from here, suppose we draw, let us name this, suppose here, name of this space is O, this is capital A, capital B, capital C. So the first thing is we have to name the spaces, and then we have to apply Vows notation. So here we have named the spaces. So the force P2, if we draw the force P2 here, suppose this is force P2, and in terms of Vows notation, the name will be AB. Okay. Similarly, BC will denote the force P1. Okay. Now, from here, basically, we can have let us take a point O here. We will call this point as pole. Now, if we join this OA, OB, OC, if we join this, now this P2 and P1 direction is known to us. So if we join this OA, OB, and OC, so these are called rays. These are rays. So we can say that O small a, small b, this is forming a closed polygon. So this ray, so P2 is resultant of these two forces, we can say. So here also in the space diagram, we can say that this P2 force is basically resultant of these two forces. Similarly, P1 is resultant of these forces. Now here I have just tried to tell you what is funicular form. Okay. Now we will find reaction of a simply supported beam using this concept only. Suppose we have a beam like this. The reactions, that is the support points, are at P and Q. we have to find the reactions at P, reactions at Q, using the concepts that we have learned previously. So this is, first of all, we have to draw this diagram. Okay, the beam, this 2 meter, 2 meter, 2 meter beam, this, the geometry of the structure, we have to draw this geometry in scale. For example, suppose, so this is form diagram, and let us take the scale as 1 centimeter is equal to 1 meter. So when you will draw this in a drawing copy, so you have to draw these things in a drawing copy, and you have to buy a A3 drawing copy. So there in the white sheet, you have to draw this form diagram first. Now we will name the spaces. Suppose A, B, C, D. So why at the bottom we have taken only one space named D? Because we know that the reactions here will be at P and Q only. So in between reaction at P and Q, there is only one space, that is capital D. So
if it would be an overhanging beam, that is the Q is some at 1 meter distance from C.
So which one?
I am telling that if it was a overhanging beam, like the Q point is at 1 meter distance with C. I mean,
Yes, overhanging beam also can be done using this graphical process. We can find the reactions for the determinate structure. Okay, for determinate structure, we can find the solutions. For overhanging beam,
then we have to annotate E. I mean ABCD E. Then E would come.
ABCD.
If it was overhanging, then E, the point E will come, the space E.
Yes, suppose here, if you have an overhang like this, suppose here, if you have another load like this, then you have to give here another space name.
Okay, ma'am.
Okay, then you will get the result. Now I am deleting this part. So here, from this form diagram, now we will draw the force diagram. So first let us draw the force 15 kilonewton. What is the name of this 15 kilonewton force? The name is AB, because we are following Vows notation. So in the clockwise direction, AB force denotes the 15 kilonewton force. So suppose this is 15 kilonewton. This is small a, small b. And BC denotes 10 kilonewton. Okay. So here scale you can take 1 centimeter is equal to suppose 5 kilonewton. So you have to draw accordingly. So now what we will do, we will take any point O here. We will name this pole. And we will join the line AO, BO, CO. So this A to B downward, B to C downward. O is a random point. O is a randomly chosen point. Now, what we will do here, now in order to get, now we know that this beam structure, this will be in equilibrium. The reactions will be such that the whole force component, all these things will be in equilibrium. So, and here, you know that the reaction at P and Q, both will be vertical here. Because all the external forces are vertically downward, so the reaction component also will be vertically upward. So here, of this OA, now using set square, what we will do, first let us extend this force lines. So, we will draw a line parallel to OA using set square from here. So, this line is parallel to OA. So, again, this is any point. This is a special case. Normally, what we should do, we have to start, we need to start this parallel drawing from the hinge joint. Okay, why? I am coming to that. But for this case, when all the loads are vertically downward, then we can start at any point here, just in the direction of the force. We know that the direction is vertically upward. So here, we have drawn this line parallel to OA. Now, parallel to OB, we will draw another line in the B space. So this line is parallel to OB. Then parallel to OC, we will draw in the C space. So this line is parallel to OC. Now, so basically, we can say that this is the funicular form of this force component. So if we assume that PQ is a string and 15 kilonewton, 10 kilonewton is the load acting at these points, then this this violet color line, this pink line, so this will form the funicular form. Okay, and in order to be in equilibrium, we have to join the first point and the end point. We have to join the initial point and the end point. Now, so this line from O, again using set square, we will draw a line parallel to this closing line. So this is the closing line. So from O, we will draw a line parallel to this. So this line is parallel to the closing line. Now this line will cut this vertical ABC here. So this point is, let us name this a small d. Then CD, this CD length will give you the reaction value, because CD denotes the reaction at Q. So CD is reaction at Q. So CD value, magnitude, in terms of magnitude and direction, it will give the reaction at Q, and DA value will give in terms of magnitude and reaction, magnitude and direction, reaction at P. So this funicular polygon is such, so basically what we can say, that this AB and O, this is creating a closed polygon. So this closed polygon is basically is manifesting the equilibrium of force at this joint, basically. Because you see, this is OA, this is OB. We have drawn these two lines parallel. And here we can say that if this is 15 kilonewton load here, so at this joint, it must be in equilibrium, like this. So a triangle here, small a, small b, O, this denotes the equilibrium of forces at a particular joint. So now, so how we can get the point D? So we have drawn a line parallel to this closing line here in the funicular form. We draw a line parallel to this closing line from O, and that will cut the line AC at point small d. So now if we measure CD, then it will give us the reaction at Q. And if we measure DA, it will give us the reaction at P. And now you can find the magnitude. Experimentally means just if you draw it and measure it, you will get the result graphically, and you can similarly find out the result analytically, and you can compare. So basically, for this RP and RQ case, we don't know the force magnitude, but we know the force direction. And both force directions will be vertical. Just I'm showing you another thing. Suppose here,
can't you know the magnitude by measuring the length?
Magnitude of what?
RP and RQ.
Yes. If you measure the length, it will give us the magnitude of RP and RQ.
Ma'am, you said we don't know the magnitude of RP and RQ.
Oh, this is, no. This is before, that is what is our unknown, basically. Our unknown is magnitude of RP and RQ. But we know the directions of RP and RQ. But after drawing this force diagram, from this diagram, we can find out the magnitudes. Okay, basically what is our unknown, that I'm trying to say. For example, suppose if we have a simply supported beam, but with an inclined load, then what will be the reactions? How you will draw this? Suppose this inclined load value is P. Then obviously you know that your reaction will be, so this P is the force. Suppose this joint is 1 and this joint is 2, suppose. So here the reaction at 2 will be vertical, because here is a roller support. But at joint A, whatever is the reaction, you don't know the magnitude or direction, isn't it? তোমরা কিন্তু এই 1 এ ডিরেকশনটাও তোমরা জানো না, কারণ এখানে ইনক্লাইন্ড লোড আছে। সো এখানে একটা কিছু আরবিট্রারি ডিরেকশন হবে। সো এটা তোমরা অ্যানালিটিক্যালি সলভ করতে পারো, কিন্তু গ্রাফিক্যালি করতে গেলে কি করতে হবে? সাপোজ this is the space name A, space name B, space name C. So AB denotes the force P. BC denotes the vertical reaction R2. And CA denotes the reaction at 1. Okay. So now, this is the form diagram. So if we draw the force diagram, so we have to draw in terms of magnitude and direction. This value must be equal to P kilonewton, and this magnitude will denote the force value, and it will be given the name as AB. Now we are drawing the force diagram. Okay. So now, if we take any point O, pole, so O is a randomly chosen point, and we have joined AO, BO. So here we don't know the position of C, because if we know position of C, then we can find out BC and CA. So in the force diagram, we have to find position of small c. So we have joined OA and OB. So here, in the A space, we will draw a line parallel to OA. But from where? Because for this R1 force, we know that this R1 force will pass through this joint. But we don't know the direction of the force till now. So we will start drawing the funicular polygon at this joint. We will extend this force line and we will draw a line parallel to OA, which will cut the force line or the extended force line at this point, suppose. Then we will draw a line parallel to OB in the B space, which will cut the next force line. So it is nearly horizontal. So this is parallel to OB. So it will cut this force line here, because for this case, we know that force is the vertically upward. We know the direction of this force because here the support is roller. Now if we join these 2 points, so this pink diagram is the funicular polygon. Now from O, we will draw a line parallel to this closing line. So this line and this line, this is parallel. So now where will be the C point? কি মনে হয়? You see, from in this, if you see this R2, this is vertically upward. So BC direction must be a vertical one. So from B, we have to draw. From B, we have to draw a vertical line. And this pink line, which is parallel to the closing line, will cut this vertical at this joint C, because BC will be vertical. So this point will be our C, and if we now join CA, this will give us the reaction in terms of magnitude and direction at 1, because CA denotes the reaction R1. So if you measure this length, it will give you the value, or you can find out the horizontal and vertical component also. So just from A, if you draw a horizontal line, then this vertical part will give you the vertical component of R1. So this is vertical component of R1. And this is the horizontal component of R1. And this CA is the whole R1. So in this way, you can find out the reactions in case of inclined load also. Okay. So, তোমরা এবার বলো আর মানে কোন জায়গায় বুঝতে প্রবলেম আছে। Then I will give you 2-3 problems that you have to solve graphically using the drawing copy. হ্যাঁ বলো। R2 মানে তুমি যদি স্পেস ডায়াগ্রামটা দেখো মানে ফর্ম ডায়াগ্রামটা এখানে বলো R2 ফোর্সটাকে কে ডিনোট করছে ইন টার্মস অফ স্পেস A B C BC তাই না BC বললে তো R2 ফোর্সটাই বোঝাচ্ছে তাই তো যেহেতু এটা ক্লকওয়াইজ ম্যানারে BC বললে R2 ফোর্স বোঝাচ্ছে সো তুমি যদি এই BC টাকে মেজার করো সো দ্যাট উইল গিভ ইউ R2
ওকে
ম্যাম R1 এর অ্যাঙ্গেলটা আরেকবার বলবেন
বলছি হ্যাং করে গেছে Suppose this is 10 kilonewton force. So this problem তোমরা note down করে নাও। এই প্রবলেমটা তোমরা solve করবে। So this is 3, this is 4. So in this way the angle of this force is given. So suppose this is P point, this is Q point, and this is S point. So you have to find RP, RQ. So you have to give the space name A, B, C. So here AB. So this is A, B suppose. So this is 10 kilonewton force. Now we will take
Center.
S.
S is center of P.
Yes, you can take it is as centered. Okay. So let us take this as 2 meter and 2 meter. So from O, we will join this. So here the force line is like this, but here you don't know. So we will draw a line parallel to OA. We will draw a line parallel to OA from P. And then we will draw another line parallel to OB. So this is parallel to OB, parallel to OA, and we will join this initial point and the end point. Now from O, we will draw a line parallel to this closing line. And this line will cut the vertical from B here. So this will be our point C. So BC, in terms of magnitude and direction, will give RQ. BC, you see, it is upward, B to C. So here also the reaction will be upward. And C to A. This is like this, C to A. So here also, if you draw using set square, you draw a line parallel to the CA here, then it will give the reaction at P in terms of direction also. And from this force diagram, you can find the horizontal and vertical component also. So this thing will denote RP. And if you want to find out the horizontal and vertical component, then you have already drawn the vertical line BC extended. Now draw a horizontal line from A. So if you name this as E, for example, so this will give the vertical component of RP, and this will give the horizontal component of RP.
Ma'am, horizontal with respect to OB.
No. OB, that need not be horizontal. OB can be any line, because if you take this O, if you take this pole here, then your drawing will look like this. Then your OB line will not be a horizontal line. So horizontal means what you can say that using set square, you have to draw a line which is perpendicular to this line.
Okay, ma'am.
Which will pass through A.
And while drawing the perpendicular line, how should I draw that?
Yes. So you have to use the set square here. Whenever you will do this drawing in the drawing copy, you have to use set square and scale. So just try to solve this total 3 problems. One is, the first case is this one. So take theta is equal to 45 degree. Okay. And this is symmetrical. So if this is 45 degree, this is also 45 degree. And find the force component. So this will be your problem number 1. So you can take this length as suppose 6 meter. And this H, that you have to find. If this is h, if this is 6 meter, and if this angle is to be 45 degree, then what will be h? H you can find out. So this will be your problem number 1. In problem 2, you will find reactions for this simple beam problem, which is subjected to vertical concentrated load. So here you will find the reactions graphically and analytically, and you have to compare the results. So after solving this, you have to form a table like this. So here, suppose reaction at P, reaction at Q. So here, graphical value. Here, analytical value. And here, percentage error. So that percentage error that you have to find out. If that error is within 3 to 4%, then it is okay. No need to redo. But if the error is suppose 6%, 7% or 10% like that, please redo the problem. Redo the drawing again. So, allowable error less than is equal to maximum, just we can say 5%. More than 5% is not allowed. And in the third problem, this will be your third problem. So this problem, you will solve it. So the similar way, find RP and RQ, and then find percentage error. Okay. So these 3 problems, try to do it. In the next class, we will discuss these 3 problems again, whatever problems you have faced, and then we will again discuss 2 or 3 more problems based on this. Okay.
Yes, ma'am.
Ma'am, kindly you show problem number 1 too.
So problem number 1. So this is problem number 1. দেখতে পাচ্ছো?
Yes, ma'am. Yes, ma'am.
অমিত আর অভিষেক, আর কিছু বক্তব্য থাকলে একটু বলো। শুনতে
পোস্ট ট্রায়াঙ্গেল হচ্ছে, এটা একটু যদি লাস্টের প্রবলেমটা দেখিয়ে দেন আর কি, লাস্টের প্রবলেম বা লাস্টের আগের প্রবলেমটা, যে ফোর্স পলিগন হচ্ছে বা পোস্ট ট্রায়াঙ্গেল হচ্ছে, এটা আর কি লাস্টের প্রবলেমটা লাস্টের আগে তিনটা প্রবলেম যে কোনো একটা দেখিয়ে দিলেই হবে।
হ্যাঁ, সেটা তো ওদেরকে বলা হলো। বেসিক্যালি প্রত্যেকটাই হচ্ছে যে আমরা একটা ফোর্স ট্রায়াঙ্গেলই হচ্ছে, মানে এই যে এক একটা ট্রায়াঙ্গেল যেটা ফর্ম হচ্ছে, সো দ্যাট মানে সাপোজ এখানে ফর দিস কেস ধরো ও স্মল বি স্মল সি, এখানে বিসি ফোর্স হচ্ছে 10 কিলোনিউটন। সো বিসি we can say this is resultant of the force BO and OC. Okay, so BO and OC. So here in the form diagram, if we see this BO and OC, and here this is 10 kilonewton. The forces will be distributed in such a way so that this 10 kilonewton will be the resultant of this OB and OC force. So it will denote this triangle OBC. It will actually denote the equilibrium of forces or the force triangle for this particular joint where this 10 kilonewton force is acting. অমিত তুমি আরো কিছু অ্যাড করতে চাইলে অ্যাড করো।
ঠিক আছে ও ঠিক আছে।
So this is the thing. So these three problems, you just try it in your home and we will discuss these problems in the next class. Okay. আচ্ছা আর বাকি যারা রয়েছো তোমরা কি অ্যাটেন্ডেন্সটা নিয়েছো গো? কে আছে দেবাশিস?
Ma'am, section B attendance I'll be taking now.
আচ্ছা আচ্ছা ওকে ওকে সেকশন বি এর অ্যাটেন্ডেন্স ঠিক আছে। সো ওকে তাহলে তোমরা মানে আর যদি কোনো কোয়েরি থাকে করো, নয়তো তোমরা লিভ করতে পারো এবার, তাই তো?
Section B kindly stay back. I'll take your attendance.
আচ্ছা সো সেকশন বি থাকো, তোমাদের অ্যাটেন্ডেন্সটা হয়ে যাবে। সেকশন এ কি লিভ করতে পারে?
ম্যাম পেজ নাম্বার 3 টা দেখান, কোশ্চেন নাম্বার 3 once more. Question number 3, ma'am. Question number 3.
হচ্ছে?
হ্যাঁ ম্যাম।
Ma'am, may I proceed with the attendance of section B?
ওকে আমি তাহলে এখানে এই করছি, তোমরা অ্যাটেন্ডেন্স দিয়ে লিভ করো, আমি এখানে মিউট করে দিচ্ছি।
Section B, am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Kindly answer your roll call. Roll number 139.
Present, sir.
140. 141.
Present, sir.
142. 143.
Present, sir.
144. 145.
Present, sir.
146.
Present, sir.
148.
Yes, sir.
149.
Present, sir.
150. 151.
Present, sir.
152.
Present, sir.
153. 154.
Yes, sir.
155.
Present, sir.
157.
Present, sir.
159.
159 present, sir.
160.
Excuse me, sir. Sir, 153 is present. My mic was having some problem.
Okay.
Yes, sir. 142 also.
142 also. Okay. Okay. Where was I? 153 you have answered, right?
Yes, sir.
154.
Yes, sir.
155.
Present, sir.
157. 157. Okay. 159. 160. 161. 162.
Present, sir.
163.
Present, sir.
164.